Welcome to Study Loop.
This is the answer to Chapter 21, problem number 88 from the Smith Organic Chemistry textbook. And this problem is essentially a ring contraction, but it's not really a ring contraction. But we're asked to draw the mechanism by which we go from this 7-membered ring to a 5-membered ring. And so it's a 7-membered ring that's an acetal to a 5-membered ring that's an acetal. And we're going to draw the stepwise mechanism, but basically it's just that one side of the acetal opens and then is attacked by a different hydroxide group to reform the acetal, but the 5-membered ring version. And so it's going to look like this. So the first step is that one of these acetal oxygens is going to grab a proton and become protonated. And so it will now have a positive charge on it because it has 3 bonds. And so the carbon-oxygen bond is going to break. Those electrons will revert to the oxygen there. So from there, we'll have this. So there's a positive charge, a carbocation on this formerly acetal carbon now. And then we have another hydroxy group here. So this hydroxy group, of course, has its own lone pairs, and one of them is going to attack that carbocation and changing the orientation around a little bit. So this oxygen has 3 bonds. And a positive charge. And then, of course, we can use water, as we almost always do. So there's some water floating along. One of the lone pairs on the water oxygen can grab that proton. Those electrons can revert to the oxygen. And it's just that simple. We are now at our final product. And so this is a very straightforward mechanism. It's just an acetal opening and then reclosing, although reclosing with a different hydroxy group. And there we go. There's our final product and the stepwise mechanism for it. And that's the answer to Chapter 21, problem number 88.